VFX. We're going to talk about our pipeline. I've titled Building a CG Pipeline from Houdini, USD, and Hope. So Dave's going to go into some of the juicy technical details a bit later, but I'll just give you an outline of who Union is. We were founded in 2008, and we work doing VFX for film and TV. Kind of got a history of specializing in 2D work, environments and effects. We work on a really wide variety of projects, as you can see here, ranging from kind of independent films to big series like Moon Knight or Sandman, and we recently finished on the series The Power, which I'm hoping to be watching on Amazon, which is a big project for us. I'm Rob Hopper, head of CG at Union. This is Dave Schneider, who's our CG and Technical Supervisor.
Good morning.
So, to kind of go back to where it all started, we joined Union in early 2020. So it seems a long time ago now, and there was a sense of positivity and optimism in the air. We're looking forward to a new venture at Union. As a company, the amount of VFX work they were doing was increasing, and the team was growing. There was a really good chance for us to, put into effect some of the things we'd learned at previous companies and also design it ourselves. So the bad news when we arrived, there wasn't really a CG pipeline as such. It was like a very small team, and things had been, should we say, flexible in the way that people were working, which has its benefits for sure. The good news was there's no real CG pipeline to also hold you back in terms of a lot of old code to maintain, or worrying about incompatibilities if we're going to do anything new, or breaking tools that are already in service on productions. So in that way, it was quite a blank canvas. In other bad news, there was a global pandemic, which some of you may remember. But on the plus side, that did mean we had a lot of time for development. We were all locked down. A lot of the projects had either been put on hold or on some kind of hiatus. So that gave us time to kind of review the situation and plan how we would build a CG workflow without worrying about having big productions in place that would break or encounter issues if they weren't working straight away. So the first kind of goals for us when we started out on this project were to smooth the workflow, get departments and artists working together, which as you grow is more difficult. You've got connecting more people, so you want a unified way of working, so that's managed better. We also wanted to manage our CG assets better through the pipeline, i.e. be able to update existing work files and scenes to bring in asset updates seamlessly, but also having a clear record within a shot of all the approved assets that you needed to complete that shot. We also wanted to be able to backtrack from reviews, things you'd seen in dailies. If someone, a supervisor said, I remember in version 3 I much preferred the model or the texture, being able to trace back, locate that, and then kind of continue from there. There were a few kind of requirements we had to work within. As a small company, we didn't have a huge development team, so we wanted to rely on third-party software as much as possible and solutions where we could find them, including the main kind of foundations of the software stack that we're using. Maya, obviously, for modeling, and lots of CG steps up to lighting, shot grid for asset management, rendering in Arnold wherever we could. Already using Houdini a fair amount, mostly at that stage for simulation work, maybe crowds, some lighting, Nuke for us, and Deadline for farm management. So as well as those kind of established software, we also had a chance to look at new workflows, and USD was the primary thing we looked at, being very interested in a very universal way of representing data from all the different departments. So if we could get that working, it would cover a lot of the pipeline in one go. And also, I had also been playing around with updates from side effects, which we really liked, like Solaris coming along, interfacing with USD, and also very excited by PDG and the potential there. it was a chance for us to kind of take some of the things we'd been playing around with and using them in a production workflow. So with those kind of conditions set up, we hand over to Dave, and yes, he started work on the pipeline itself.
Yeah, thanks, Rob. So, yeah, as Rob says, March 2020, I just moved over to Union. I had one shiny day in the office, walking around, meeting everybody, and then that evening, Boris Johnson got on the telly and told us all we had to stay at home. So it was a very interesting start at Union for me. We had some days of semi-normality ahead of us, working on projects, but as Rob says, once that initial work died down with all the sets closing, it left me with a fair bit of time in my hands to start thinking about pipeline. So the first place that I started was with some guiding principles. I was trying to come up with some points that would inform the future development that was to come. So let's go through those. First off, artists should never have to search for the assets they need. In those few months that we were still working on shows, I heard a lot of things like, people asking which camera they were supposed to use or what was supposed to be in the scene. And we had a lot of instances of artists sending emails around, trying to dig up old emails, old chat messages, trying to figure out what exactly it was they were supposed to be working with. That's obviously not great. Artists should never have to figure out which asset version they should be using. I saw quite a few fairly expensive shots getting rendered and then re-rendered and then re-rendered because people didn't actually know which was the correct camera. As happens in production quite often, we had several versions of cameras, and you would find that the clients had actually approved version 6, but our latest was version 9. And people's first instinct would be to pick up the latest available, but you would have to then roll back and figure out which one you were actually supposed to be using. Artists and supervisors should be able to easily inspect the current state of a shot. So when you're working like that and you don't really have much of a pipeline, if the supervisor wants to know what all the latest material is, the only way you can really do that is to make sure that everything has been rendered and then slap comped together. And once that process is done, you of course find out, okay, hold on, that's not right, and you kind of have to go back. And again, it's render time. We're a small to medium-sized studio. We don't have a crazy huge render farm like some of the bigger facilities, so this time it's valuable to us. We don't want to be spending render time on things that are just for QC or just checking the state of a shot. An asset version should always be linked to the scene file that created it and any dailies that show it. So we want to, again, be in a position where you can be reviewing dailies, you can be rolling back to dailies from a month ago, 2 months ago, and very easily be able to track back to the scene files that created all of the material for those dailies. What you will find, for those of you working in production, this will be familiar to you. Sometimes clients can say, actually, we kind of like what we did a couple months ago. Can we go back to that? And that's often a bit of a nightmare when everyone starts scrambling, checking timestamps. Okay, this was the 4th of February, so which scene file would I have used to do that? We want all that information available so that we can just easily track back and recreate versions. And finally, again, as we don't have an enormous pipeline team, at the time during the pandemic especially, we were getting quite small for a while. That pipeline team was really came down to one full-time developer and me, and I was kind of dividing my time between this and CG supervision. So I made the decision that we don't want to be in a position in the future where you have to have a team of full-time software developers to maintain and extend your pipeline. We wanted to do it with as little custom code as possible so that all it would really take would be an experienced Houdini TD to be able to go ahead and maintain the pipeline. So let's do a quick sidebar. Rob mentioned that we wanted to look at USD as our core technology. So a lot of the sort of initial research that I did was just getting to grips with USD. It has a learning curve that rivals the Grand Canyon coming up from the bottom. So USD, Universal Scene Description, created by Pixar. It's two primary functions, as far as we're concerned anyway, like Alembic, the storage and interchange of 3D geometry. So it's very, very good for letting you basically dump out whatever it is you're working with into a common format, which can be understood by other applications. And it's also very good for the description of your scenes. You can store USD files in an ASCII format, which makes them very readable for if you're just using them for the purposes of referencing other USD scenes or geometry that you've created. So it's really, really good for describing the contents of a shot or a sequence. It can store light rigs and material networks where supported. This was another important thing for us because we wanted to give artists a degree of flexibility. We wanted artists to have the freedom to move with whichever software package they were more comfortable with. So we liked the idea of being able to create light rigs, material networks in one piece of software and then publish it out to a pipeline and then pick it up in another piece of software if the artist further down the pipeline is more familiar with, say, Houdini over Maya or Maya over Houdini. So a USD scene or stage is composed from multiple layers. So this means that every department can be working on their own layer of the shot, and then these all kind of get overlaid on top of each other. If you think about transparencies, if anyone here remembers overhead slide projectors, if you write in a bunch of them and you put them all on top of each other, each one of those is a layer, and the final result you're seeing projected on the screen would be your stage. And this allows artists to be quite efficient because this means they can only load and display the sections of the final composed stage that they actually need. So if they're a lighting artist, then they're only going to be rendering a section of the scene. They don't need to load in, say, all of the really expensive Houdini simulations that they're not actually rendering at that point. So talking about data and scene management. So how do we do the scene descriptions? A lot of studios have different names for this concept. Some studios call them, say, shot packages. Some call them bundles. We're calling them manifests. A manifest describes the contents of a shot or sequence. And in our case, these are constructed from a hierarchy of USD files in ASCII format. This hierarchy is stored alongside the file structure that contains all of our scene data. It's version controlled, so every time you create a new version of the manifest, it versions up, that gets published to ShotGrid, and that means we can always go back to a comprehensive state of a shot from any point in the past. In terms of data management, scenes, shot data, manifest files, they're all published to ShotGrid. When we arrived at Union, we were already using ShotGrid for scheduling, shot management, asset management. So it seemed the most logical thing to keep going in that direction. So everything that we generate is published as published files on ShotGrid. So let's go into a little more specific tech that we wanted to work with. As I was doing my research into USD, I found out about USDZ, or Z, depending on who's watching this. USDZ is a zip-based archive format, so it is essentially a zip file. You can rename it to a .zip and unzip it, and it'll work. What it essentially is it's an archive format. It's mainly gets used on Apple devices, I believe, which kind of support them natively with certain restrictions. But the USD toolkit comes with an application called USDZip, which is very good for being passed a USD geometry file and then figuring out what all of its required assets are. So, well, primarily we're talking about textures here. And it can then go off, gather in all those textures, construct them in a hierarchy underneath the root USD file, rewrite all of the references to point within its own archive. So this means it's really great for storing assets. I got really excited about this, and I figured this would be a way of us storing, a single file that if you needed to archive or transport an asset, just that one file that we would need to send to our clients or to another studio or to render, and we would always have the correct versions of the textures at the time of publish bundled up with the asset itself. PDG, some of you may be familiar with, that's an aspect of Houdini. It's a context of Houdini. Which, like the rest of Houdini, is a node-based workflow. And what it's really good for is describing pipeline logic. Whereas in any other context in Houdini, I would say what the nodes are doing is moving data around inside Houdini. PDG is really good for moving data both inside and outside of Houdini. So there are stock nodes which can be used for grabbing data from ShotGrid. And then you can go off to, say, Maya and generate an export of some geometry, pass that into Houdini, do a simulation based on it, cache it out, upload that to Shotgun, etc. So I had a look at this and I decided that this would be a really good way of describing our pipeline logic because, again, it'll mostly be, or almost exclusively is, stock Houdini nodes. And we could hire people in, people with Houdini experience who come in, look at this and understand what our pipeline's doing. And then the final piece of the puzzle here is Houdini Engine, or the Houdini Engine API, which amazingly is called Happy. Houdini Engine is the system of plugins that SideFX created for other DCCs. So we obviously had the problem, okay, if we're going to implement a pipeline largely inside Houdini, we obviously still have a lot of artists using Maya and other software, so how do we account for them wanting to publish material? And so the standard Houdini Engine plugins, what they let you do is load in a Houdini digital asset that you've created and then run that from the context of another application. That is obviously took my attention at first. That was sort of my first approach to this is, okay, so we bundle everything up in a digital asset, run it in Houdini Engine. That's not quite how it ended up working out, which I'll explain more when I show you the architecture. But we are using the API to essentially connect to persistent Houdini Engine sessions that are running on our render farm. So some of the design decisions that we took after the initial research phase, we wanted as much as possible to have a unified interface through ShotGrid apps. The artists were all pretty familiar with using the ShotGrid publisher, the ShotGrid loader. And I figured that, these are quite flexible. You can write the hooks that you need to do whatever logic you want through the loader and the publisher. And so I decided, let's make that the front end to whatever it is that we end up doing, because that's what everyone's going to be familiar with. And ShotGrid toolkits are available across different DCCs, so it meant that we were guaranteed to have the same interface across all of our DCCs. So it's the publisher and the loader. All logic implemented in Houdini. So again, I decided as much as possible I wanted things to be off the shelf. I wanted it to be self-contained. So I decided, okay, so we can use Solaris to get everything into USD formats and structure our assets the way we want them to be structured. And then we can use PDG graphs to do all the actual pipeline workflow logic. And this can all be packaged up as Houdini digital assets. And then, as I said before, we can use the Houdini Engine system to plug it into other DCCs such as Maya. And then how do we put the manifest together? So I decided, okay, we're using ShotGrid for everything else, for scheduling, for finding assets, etc. So let's create a custom entity in ShotGrid called manifest, and we'll make a page for manipulating them inside ShotGrid. And then that's something that artists are broadly already familiar with. And finally, an old, from my distant past as a professional software developer, an old adage I always liked, KISS, keep it simple, stupid. So again, let's keep it simple. Let's try not to go into the realm of custom code, custom Python, custom C++, where, one day in the long and distant future, somebody comes along and decides they need to make a change to the pipeline, but they're looking and they don't understand the code, they don't understand what's written, they can't compile it. Let's just get away from all of that. Let's keep everything stock as much as possible. So here's a basic look at the architecture of our pipeline. So starting with Houdini in the bottom corner, that's pretty much the most straightforward workflow. So you have decided to model an asset in Houdini, you model it, you texture it, you look at it, you want to publish it. All you have to do is you create an instance of our what we call UAsset publisher, which is our digital asset containing all of our pipeline logic. It'll bring up an interface, which I'll show you in a moment. You plug your geometry into that, hit go. It'll do everything it needs to do, send it off to our render farm via Deadline, which is our render management software, and that'll get published to ShotGrid. Now, the more interesting part of that is, okay, you're in Maya. So as I said, if you want to then publish something from Maya using the ShotGrid publisher, what's going to happen in between is the Houdini API is going to kick in, and it's going to connect to one of, I think we have 10 persistent, they're called HARS sessions. I don't know how many people have heard of HARS, but it's a binary that ships with Houdini and is essentially a headless Houdini session that can just run on your machine or your render farm. we have a bunch of those just running on a single blade on our render farm behind a proxy, which load balances pipeline requests coming in to one of those headless Houdini sessions, which will then create an instance of the digital asset under the hood, plug in the data from Maya, which has been exported as a temporary USD, and then do the exact same routine that happens as if you were publishing from Houdini. So let's take a look. I've recorded some videos of the pipeline in action to give you a more visual representation of what it is we're doing. So let's take a look at this one. So over here you have a venerable Airbus A340-200 that we modeled. So let's say I'm an artist in Maya and I want to publish this. Okay, great. So I hit the button to create a release set. I put the top level of my geometry into the set. I make sure it's named correctly. Okay, it's a geometry type publish. Great. Let's go to the shot grid menu and hit publish. And what we're going to get is the standard shot grid publish dialog, which some of you may be familiar with. There's a little bit of custom code here just to make a custom panel, which allows us to expose some of the options from our Houdini digital asset, such as whether or not to render a preview turntable. Hit publish, and what is happening behind the scenes now is that the Maya USD exporter has kicked in. It's exporting our geometry along with any Arnold shading networks that are attached to it. And that's being written out. You might be able to read in the bottom corner, that's being written to a temporary location on our storage where the USD file is being stored. So that'll be done in just a moment. And now what's happening that you can't quite see is that behind the scenes, the Houdini API has been invoked, and we are now passing that USD over to one of those Houdini sessions running on our render farm, which is plugging it into the digital asset and then sending it off. So what you're going to see here is, just because we are using, as I said, the standard publisher, it doesn't know this is all going on behind the scenes, so we get a little publish complete message. But if I switch over to deadline, you'll see that what's actually happened is that those Houdini instances of the farm have kicked off a PDG graph, which is now running as a standalone job in our render farm. So I'm just going to put this one to skim through. What you're seeing here is the job now running on our render farm. So the slightly tricky thing with PDG, if you're going to run a job on the farm, is that you, of course, aren't going to get an exact representation of what your job is doing, because the various render softwares don't know how to accurately present a PDG graph. So we've done what we can to split things out into sub-jobs, so at least artists and render wranglers in particular have a decent idea of which particular stage our publishers are at. You can see what's happening right now. It's created the geometry outputs, and it's busy rendering out all of the preview frames. So when these are done in a minute, there'll be more aspects of the PDG graph that kick in, that go off and take a look at the geometry being published. It'll generate some statistics. It'll use image magic to then overlay those on the final frames. And we should be done in just a moment. So so now we have our QuickTime of our preview render going off to the farm. That's going to get published, and you end up with a nice little preview render showing off the asset that's just been published. So that's now been published. So how do we work with these things? So as I said, we go to the shot grid loader, which is standard across DCCs. We go and we find the context that we published into, in this case my little FMX shot. And there we go, we've brought back in that geometry as a native Maya USD proxy shape. Let's put down an Arnold light. And we see that rendering just as we had it before, so we know that all the materials and textures are correctly attached. But now, okay, what if you're a lighter and you decide actually you want to work in Houdini instead? Exact same process. We go to the shot grid loader. Let's find our asset and import it. Let's go to the Solaris context so we can see the native USD. There it is. Again, we just drop down a dome light, switch to the Arnold render delegate. And what we're going to get is the exact same result that we just saw coming out of Maya. So this asset is now ready to be used as part of a layout. It's ready to be lit directly, if that's the stage you're at. And artists have the freedom to bring that in wherever they want to use it and however they want to use it. So let's take a little tour of our digital asset that contains this logic. So we're in a standard Houdini session here, and our old friend, the rubber toy, is waiting for us. We have connected that up to our asset publisher, HDA, which is now showing us a preview of the output. You can see that if you look at the parameter pane, you'll see the various options we have for flexibility. You can choose which turntable renderer you want to use, Arnold or Karma. We've got scale conversion. We've got 3 different output formats, USD, USDZ, and Alembic, which are all enabled by default. We've got automatic log generation, so we can automatically decimate our assets at publish time if we want to use them for preview purposes as well. And we have our render controls, which let us control what sort of preview output we get. So, for example, if you want to fine-tune the render turntable, or perhaps specify the HDRI backdrop that's going to get used for that, you can do that. So let's crack this open and look at the meat of it. The 2 main areas, we have our Solaris graph over here, or the LOP network in red. And below that, we have the PDG, or top network, in blue. So let's... Okay, great. So let's have a quick look through this. So this is showing you the various aspects. I'm going to put this on a slightly higher speed. We don't have to go into the technical details, but if anyone's interested, I'd be happy to talk it over afterwards. Basically, we have various input branches depending on what it is that you're publishing. It could be coming from Houdini, it could be coming from a batch of data we've been sent by clients, or it could be coming from Maya. And then we've got various areas of our Solaris graph for either, this is the model generation over here with all of our LOD generation. We've got our animation publishing, deform, transform, any other kind of cache. We've got direct input from Solaris, if that's what you want to publish. We've got specialized crowd publishing. And this is all implemented as standard stock Houdini. And then just skipping ahead, this is just what's going to come out of your render turntable. And then if we switch over to our PDG graph over here, you can see this is the actual pipeline logic. These nodes in purple, that's all ShotGrid. That's going off and getting information we need from ShotGrid. The boxes you're seeing in gray are our various geometry export formats that are being produced. The multicolored boxes are our preview renders, depending on the type of publish. And that's where it all gets published into ShotGrid. So just for illustration, let's again go through this quickly. This is just going to illustrate to you what is actually happening when you launch a publish. So as I said, we go off to our render farm, and what's really powerful is if we look at that log, we can extract the PDG data layer server from there. You can go over to a Houdini session, plug that into a remote graph, and now we can see exactly what's happening on the farm. So if you can't decide just from looking at deadline what's gone wrong, you can actually bring up the entire pipeline workflow graph and monitor it as it runs through on the render farm and figure out exactly where your issues may be. And finally, just to show you, this is then once all of your assets are published, this is our manifest management system on ShotGrid. So it's a page that has slots for all the various types of data we'd need. Those can all get plugged in from the ShotGrid publishers. And then once you are happy with that, you bring up our manifest publisher, which is a custom ShotGrid app that we've written, very small and lightweight. It shows you the conversion into USD of everything that you're trying to publish. And if you hit the preview button, you get USD view coming up to give you a nice, very easy to understand preview of exactly what is in your shot and sequence, which is a very, very useful tool for leads and supervisors. Okay, so what has the impact been at our studio? Solaris adoption is growing. We're finding, especially in layout and lighting, people are really enjoying working with Solaris. Those graphs can be plugged directly into our publisher, so it's very easy for people to publish their work, and people are really enjoying that. Greater artist freedom. We've got lighters that are literally within the same sequence on a show. They're changing between Maya and Houdini, just depending on the shot and its requirements. There's a shot with a lot of crowd, maybe they'll use Houdini to render it, then they'll switch back to Maya after that if that's where they're more comfortable. It doesn't matter, we get the exact same outputs from both, the exact same visual quality, and they're really, really happy with that. And there's less wastage because as we're doing our QCs at publish time, we can spot immediately that if we have the wrong camera or we have the wrong animation caches, those can be fixed very quickly before it ever sees the render farm. So why do we have hope mentioned in the title of our talk? Well, this pipeline was being developed, say we started about 3 years ago. I knew that when this was being developed that it was rely on a lot of third-party support. The DCC support for USD was and is still maturing, so there are certain features that maybe we don't have yet that I would like to have for the pipeline to work the way that I want it to work. And there are still, of course, bugs, as expected, across DCCs and different renderers, things that don't quite work that we would like to work and just aren't quite there yet. For example, we can't use USDZ as our primary format because none of the renderers understand yet how to reference the textures inside those archives. It is part of the spec, but I'm hopeful that in the next 6 to 12 months, we'll be at a point where we can switch to USDZ as our primary format and leave the uncompressed USDs behind. What's next for us? Better backtracking. As I said, one of our guiding principles was being able to track back from an end result to make sure that all of the material can be gotten back to very easily. We're not quite there with that yet. We still need to make sure all that metadata is passed from step to step, but we're working on it. Improved support for layout publishing. Layouts is pretty easy to do in Solaris. That's working nicely in Maya. It's a little more difficult because we want people to be able to load in the native Maya USD proxy shapes, move those around, publish them. At the moment, the Maya exporter can't actually handle those. So that's something we're working on ourselves and hope to feed back to the project. And we want to do a standalone manifest manager. Doing it inside ShotGrid was a good approach to start with. But kind of as things are maturing, we're finding there are things we'd like to do with constructing our manifest, which you can't really do through a browser interface. So we're looking at creating, hopefully, what will be a fairly lightweight standalone Qt Python application, which extends USD view so that you can have a 3D viewport and you can be adding things to your shots and sequences and seeing them populate in the viewport in real time. And some of you may have heard that Union is going multi-site. We've just opened the doors to our Montreal office, so there's some work there to do as well to make sure that everything the CG pipeline is doing is consistent with a cross-site approach. So, thanks for listening today, and can we take some questions?
I don't think we have any time for questions, unfortunately, but you guys will be around outside?
Yeah, I think Rob and I are going to head to the Union recruitment booth after this, so if you'd like to come and ask us some questions, please come around, and yeah, we'd be happy to chat and take your details if you're interested in coming to work for us.
Fantastic presentation. There's nothing I like more than a nice, efficient pipeline.
Thank you.